Hi, good evening, everyone. This is Shefali Singla, and in the session, we will be talking about the concept of indexing. So, we are going to start with our file structures. Those who have joined the session, guys, quickly give me the confirmation and then we'll start with indexing. So, in today's session, first of all, we'll understand the concept of indexing. We'll learn about the terms that we'll be using throughout this topic. And after that, tomorrow, we will be talking about the concept of multi-level indexing, dynamic multi-level indexing, in which we'll be covering the concept of B trees and B plus trees. Okay, so this is the agenda. So we'll also look at the types of questions that can be asked on the basis of indexing. So first of all, basically index files are used to organize the database file. So we know that in the database we are having a lot of data which we have to manage. So this database file is divided into the blocks or the pages. For easy reference मैं आपको बता देती हूँ. जब भी आप चीजों को रिलेट करोगे ना, you can relate it with the book. टेक्स्ट बुक सबने देखी हैं, सबने यूज की हैं, so you can relate it with that. So database file is divided into books or pages. For example, आपके पास database की book है and that is having 1000 pages or 1200 pages, तो पूरा content एक sheet पे नहीं आ जाता है. So that is divided into the parts and that is known as the blocks or pages. अब ये जो blocks और pages होते हैं in the database file, it can be fixed length blocks or variable length blocks. What do I mean by these fixed length blocks? Let us assume that we have a database. This is a database file and it is divided into the fixed size blocks. Let me call this as block 1. This is block 2. If you see here, this is of fixed length. Block 3 and block 4. Looks like this is bigger than the previous blocks. So let's see. This is block 4 and let me take here one more block 5. So these blocks are of fixed length. So this is the representation for fixed length blocks. Just like in book, so if you look at the pages of the book, कोई भी text book है, pages की length same होती है irrespective of how much data or how much words are present on each page, right? That is the example for the fixed length block. Similarly, we may be having the variable length blocks. That means the size of each block is different. If we want to store more data, so block size will be more. If we want to store less amount of data, block size will be less. So in this case, definitely there is no problem like the internal fragmentation, whereas in fixed length blocks it may occur. So in variable length blocks, the size of the blocks is different. This is block 1, this is block 2, block 3, something like this, block 4 and block 5. Okay, this is for variable length block. अब major difference कहाँ पे आता है? Since it's a fixed length block, so this if we know the base address, it's just like an array. Array में होता है हमारे पास, we know the, if we know the starting address or the base address of an array, we can randomly access any element because the size of each element or the memory assigned to each element of an array is same, because array is going to store homogeneous data, so randomly we can access any element. Similarly here, if we know the starting address, we can randomly access any block. So for fixed length blocks, if we know the base address of block, we can access any block. Whereas in variable length block, for example, I want to access block number 4, I cannot say कि पहले 3 blocks को skip कर दो and size of each block is something like X. We cannot do that because this is a variable length block. So in order to maintain the offset, the addresses of these blocks, we have a database file header. It's the responsibility of the database file header to keep track of the addresses of the blocks. This is database file header. So the information related to each and every block will be available under this header. For variable length blocks, there is a block header to access the blocks within the database file. And this block header, ये जो हम block header की बात कर रहे हैं, block header consists of a pointer which points, this is about the database file. Further in the blocks, we are going to store the records. Block is just like one page, block or page. अब pages के अंदर हम क्या store कर रहे हैं? We are storing the data. We are storing the records. So block header will be containing the pointer to which it will be pointing to every record of the file. Very good afternoon, Kanchan. So this is about the division of the database file. Now we'll be talking about the division of each block. The way we have divided the file into the blocks, उसी तरीके से हमारे पास जो block है, that will also be divided. So I have to use this slide only. Let us assume that this is representing one block. This is one block. Now further, inside this block, record can be of fixed length or of variable length. For example, this is record 1, this is record 2, record 3, record 4. This is the fixed length records. Here in a block, I have taken fixed length records. And on the other hand, we might be having the variable length records. Record 1, this is record 2, record 3, record 4. And here, since it's of variable length, so we need to maintain the header. And now, since this is the header of the block, so we'll call this as a block header. Block header. Inside this block, this is one block. And inside this block, we are storing the variable length records. Make sense? So in order to access any record from a variable length record, so for that block header is containing the pointer, and this pointer will be pointing to each and every record of the database file. यहाँ तक clear हुआ? Now my question is, question ध्यान से सुनना, which approach will you be preferring? Whether will you be referring to the fixed length records or the variable length records? किसको prefer करेंगे? If you compare these two, so obviously difference कहाँ पे आ रहा है? In the variable length records, we need to maintain the block header. In the variable length blocks, we need to maintain the database file header. So basically, what is this representing? This is representing the overhead. क्योंकि हमें यहाँ पे header maintain करना पड़ रहा है. So fixed length records are preferred. Fixed length records are more useful because in that case, we do not need any header. Let me write this point. Fixed length record is more useful because we need not to maintain any header. तो इसके बाद जो भी हम records की बात करेंगे, we will be now talking about only the fixed length records. Is this clear? Difference between the blocks and the records clear? It's just like, दोबारा से मैं repeat कर रही हूँ, book का page है, मैं throughout our example, throughout our concept, I'll be considering the example of the book. चाहे हमें index discuss करना है, book में अगर आप देखोगे, if you have to refer to any topic, so there is an index file. अगर directly बिना index को refer किए, if you are searching for any topic, that will be taking a lot of time because एक के बाद आप next page को check करोगे. That is nothing but linear search, and we know that for linear search, the time complexity is linear time complexity, that is order of n. Make sense? So this is the introduction. Now, this is a good point. Records are stored into the blocks in two ways. One is known as the spanned organization and the other one is known as the unspanned organization. Spanned organization means the record can be spanned between two blocks. दो blocks में span करना means divide करना. For example, let us assume that we have the block size as 100 bytes. Assume, this is just for our assumption. I'm assuming that we have a block of size 100 bytes and the record sizes 40 bytes. Here also I will consider the same thing. Assume block sizes 100 bytes, record sizes of 40 bytes. Now in this case, what will happen for spanned organization? Let us assume that we have 4 blocks. This is block 2, block 3 and block 4. This is block 1, block 2, block 3 and block 4. Size of each block is 100 bytes, यानी कि एक block के अंदर आप 100 bytes data store कर सकते हो. This is 100 bytes. One record is taking 40 bytes of data. So एक block में कितना data store करवा सकते हैं? It will be 2.5, यानी कि दो records तो completely आ जाएंगे. This is record 1. Size कितना है? This is of 40 bytes. Remaining is 60 bytes. Then again record 2 is coming up. This is of 40 bytes. Now we are left with a space of 20 bytes. यानी कि record 3 is stored in two blocks. Record 3 का कुछ part block 1 में आ रहा है और कुछ part किस में जा रहा है? Block 2 में. यानी कि 20 bytes it's taking from here and remaining 20 bytes it's taking from the next block. So this is known as spanned organization when a record is spanned between two blocks. Right? Now total it comes out to be 40 bytes. Total 100 bytes was there, 20 bytes is used. So record 4, this is taking 40 bytes and record 5, this is taking 40 bytes. Okay, this is known as spanned organization. Next, record 6, record 7, 40, 40 and record 8 will be spanned over two blocks. This is record 8, record 9 and record 10. Correct? So this is spanned. This is spanned organization. So if we have to calculate the block factor is nothing but it simply represents that how many records we can store in a block. So in spanned organization, block factor is nothing but that is block size. एक block में आप कितने record store करवा सकते हो? So that is block size upon divided by the record size. If we look at this assumption, so we have block sizes of size 100 bytes and record is of size 40 bytes. So this comes out to be 2.5. This indicates that in one block we can store 2.5 records. So दो record completely आए, third record आधा आए. Same goes with the block 3, block 4 and block 5. Okay. So block factor represents, let me write the definition here. Block factor is returning the number of records in a block. Similarly, in unspanned organization, unspanned means whole record should be in the single block. That is, spanning of record is not allowed. That is unspanned organization. यानी कि एक record को आप दो blocks में divide नहीं कर सकते. So here, if we look at this through the diagram, let's assume that here we have three blocks. I'm just considering three blocks here. That will be sufficient to understand the concept. Block 1, block 2 and block 3. So here, uh, in each block, how many records we can store? We can calculate the block factor here. Block factor comes out to be block size upon record size. That is the formula for the block factor. So it comes out to be 100 divided by 40 bytes, that is 2.5. But पॉइंट में आंसर नहीं ले सकते क्योंकि एक रिकॉर्ड एक ही ब्लॉक में स्टोर होगा. सो हियर वी कैन नॉट टेक इट सील वैल्यू. सील वैल्यू क्या शो करेगा? दैट सील वैल्यू ऑफ 2.5 is 3. But 3 records cannot be stored. So here we have to take the flow value. So this means that in each block we can store 2 records. So I'm storing record 1 and record 2 in block 1. This is of size 40 bytes. This is of size 40 bytes, but block ka size is of 100 bytes. So what about this 20 bytes of memory? This 20 bytes gets wasted because it is not getting assigned to any other record. Similarly, record 3, record 4, and then 20 bytes will be left out. This gets wasted. Then is record 5, record 6, and then this memory gets wasted. This is the concept of unspanned organization where the record should be in a single block only. That means we cannot divide the record. Now, can somebody tell me that out of spanned organization and unspanned organization, which method, which approach is preferred over the other? जब हम डेटा को स्टोर करवाएंगे, रिकॉर्ड्स को स्टोर करवाएंगे, whether will be going for the spanned organization or the unspanned organization? क्या प्रेफर करना चाहिए? What do we need to refer here? I hope I am audible and visible because except for good evening or good afternoon, I haven't got any response. Come on, guys. There is nothing like right or wrong. I just want you to discuss the points. Okay, let me give you a hint. When we talk about selecting the algorithm, let's assume that we are given with some problem and we have more than one solution for the same problem. एक problem को solve करने के एक से ज़्यादा तरीके हो सकते हैं. तो on what basis we are going to select that which algorithm will be going to the implementation phase? कैसे decide करते हैं? For that, we go for the concept of analysis, and analysis करके we identify that what is the time complexity required and what is the space complexity required, right? Time complexity and space complexity may say obviously the time complexity is preferred because we know that nowadays memory is getting cheaper day by day, but it's the time which we want to improve. That means we want the results in less time, in the minimum time. That means the time complexity is preferred over the space complexity. If you see here, now we'll apply the same concept here. अगर मुझे record 3 को access करना है तो मुझे database से 2 blocks को retrieve करना पड़ेगा. I want to transfer 2 blocks from the database to the memory because in order to access record 3, some part is available in block 1 and block 2. If I want to access the data of record 8, I need to transfer 2 blocks from the memory. So this means that space बचाने के चक्कर में जब हमें data transfer करना पड़ रहा है, we are referring to 2 blocks. Right, so access time will be more, but here since each record is available, since each record is stored only in a single block, so this means that किसी भी record को access करने के लिए we need to transfer only one block. So here in unspanned organization, the IO cost is less. IO cost is nothing but it simply determines that how many blocks we need to transfer from the database to the memory. Right? So unspanned organization may, since the IO cost is less, so that's why unspanned organization is preferred. Make sense? Make sense? So this is unspanned organization. If we look at the advantages and disadvantages of the spanned and the unspanned organization, advantage of spanned organization is there is an in span organization there is no fragmentation और no memory leak. कोई भी स्पेस आपके पास खाली नहीं बचे, जितना भी स्पेस अवेलेबल है, some part of the record is getting stored there. So that is the advantage of span organization, that is it is targeting on saving the space, so there is no internal fragmentation or no memory leak. But if we talk about the disadvantage of spanned organization, so sometimes in order to access a record, we might be transferring more than one block from the memory, and that is it results into the more IO cost. So in order to access the record, we have to access both the blocks. अभी हमने example में देखा, that means we need to transfer the blocks from secondary memory to the main memory. So it results into more IO cost, that is more time is required. It's saving the space, but more time is required. Advantage of unspanned organization, that is less IO cost. Means less IO cost means less time is required to access the record. Whereas the disadvantages in the unspanned organization, memory leaks are possible. अभी हमने example में देखा 100 bytes was the block size and 40 bytes was the record size. So 20 bytes of memory was getting wasted per block. So that is the disadvantage with unspanned organization. Unspanned organization is preferred over spanned organization. Reason is as time complexity, time is preferred over space. Clear? Yes. So this is about span and span organization. This is the announcement for you guys, especially for the students who are following my session for the first time, जो इस channel पे नए हैं. Guys, we have an official telegram group, that is Shefali ma'am Testbook. आप search भी कर सकते हो, और the link of this group is given in the description box. Just follow that link and you'll be taken to the group. And in this group, I'm sharing the PDF of all the YouTube sessions. जैसे आज वाला अभी जो session चल रहा है, in another 15 minutes, you will get the PDF so that easily you can revise the concepts. And the main agenda behind this is during the session, आपका full concentration, full focus concept understanding पे हो, rather than taking down the notes. Okay, it's very easy to get the notes from anywhere, but no one is going to clear the concepts. That too online, lot many recorded sessions are available, but live session में जैसे आप interact कर सकते हो, doubts पूछ सकते हो, so it's not there. So I want you to utilize that opportunity to the fullest. So for that, don't focus on noting down the things. I'll share the PDF with ink. जो मैं चीजें लिख रही हूँ वो भी in fact उसमें आएंगी. Okay, but definitely during the session, if I'm giving you some question to try solve करने के लिए क्वेश्चन देती हूँ, तो definitely I give time for the same as well, like 30 seconds or 1 minute, depending on what is the length of the question and what is the requirement of the question. तो उस time पे you are supposed to solve the question. Otherwise, don't write anything during the session. Session के बाद जब आप revise करोगे, उस time पे notes बना लो. Okay? Apart from that, you can also participate in the discussions and the doubt solving. So in case if you have any doubt, you can post that in the group. You can directly interact with me. You can participate in the quizzes and the polls. Again, the link of this group is given in the description box. That's the third link. अगर आप count करोगे, so that's the third link in the description box. If still you are unable to locate it, नहीं मिल रहा है, then towards the end of the session, I'll be sharing my screen and you can see what links are available in the description box. All right. Moreover, if any announcement is there from my side, or I want to discuss, or I want to convey my message to you guys, so this is the only communication channel through which I can convey my message. Okay. All right. So now there are few terms that will be using through uh, that we'll be using in this concept. One is the search key, audit file, and the IO cost. Already we have talked about the IO cost. This is nothing but the number of blocks transferred from secondary memory to main memory in order to access some record. किसी रिकॉर्ड को एक्सेस करने के लिए आपको कितने ब्लॉक सेकेंडरी मेमोरी से मेन मेमोरी में ट्रांसफर करने पड़ रहे हैं, दैट इज नोन एज द IO cost. Already we have talked about this. Search key is nothing but this is some attribute because see, if we have a large database, there must be some attribute on the basis of which we'll be performing the search operation. For example, we have a student database and I want to retrieve the information for the student. So I might be using the key as the ID. So I'll be writing a query like, I want to retrieve the marks of the student with the student ID 1234. So student ID is behaving as a search key. Make sense? And second term is the ordered file. Ordered file means whether the database file is physically ordered on the search key attribute or not. What do I mean by this statement? For example, we have a student relation, and here we have the attributes like student ID, student name, marks, address of a student. So if student ID, I'm considering a student ID as the key. We have 1, 2, 3, 4, and the student name is John, Mary. Two students can have the same name, John, and let's say Cinderella. Now marks are something like 90 marks are obtained in DBMS, 85, 80, and 92. Address is something like we are not bothered about the address. So if you see here, in this case, search key is I'm writing retrieve the marks of the student with student ID as 3. So this means that I'm searching for some record on the basis of the student ID. So this student ID is behaving as a search key for this database. Student ID is the search key. Ordered file का मतलब क्या है? ये जो search key है, this file is ordered because यहाँ पे जो आपके पास student ID है, that is coming in one particular sequence. So this file is ordered. अगर मैं यहाँ पे search key is SID, if I'm storing this as 3, 2, 4, 2, 3, 1. So this is the search key and this is unordered. This is unordered. I'm not constructing the complete database again. Make sense? So these are the few terms that we'll be talking when we'll be discussing the concept of different types of indexes. Next one is indexing. Okay. Can somebody tell me that what will be the IO cost for the ordered file and the unordered file? Because ultimately, anyhow, at the end, we are concerned with the IO cost because we have to retrieve the data. So for the ordered file and for unordered file, what will be the IO cost? I want to retrieve some data whereas the file is ordered. What will be the IO cost? Let me give you a hint. Let us assume that you are given with a set of elements which are sorted. Ordered का मतलब क्या है? Sorted. So if we are given with a set of elements which are sorted and you want to access particular element, what will be the IO cost? किसी एक element को search करने. Sorted array में you are searching for one element. Which searching technique will you be using? I guess इसके आगे कोई hint नहीं मैं दे सकती हूँ. इसके आगे फिर answer आएगा. Ariya? We are given with the sorted array and I want to search for one element. Which searching technique will you be using? We have talked about the linear search and the binary search. Yes, file is ordered. हमारे पास searching में linear search आता है, binary search आता है. When can we use this binary search? Binary search means we'll find the middle element. If the required element is smaller, we'll go to the left side. If the required element is greater, we'll go to the right side. So this way we can discard half of the elements in each step. So that means binary search. अगर elements sorted ही नहीं है, we cannot decide whether we have to access the elements which are available in the first half or which are available in the second half, right? So binary search is applicable on a sorted file, whereas linear search can be applied on sorted or unsorted. But sorted पे हम prefer नहीं करते because the IO cost or the time complexity for the linear search is more. Time complexity for linear search is order of n. We have already discussed now. And for binary search, this is order of log n. Obviously, logarithmic time complexity is much smaller than the linear time complexity. Same thing we are referring here, almost same concept here. If the file is ordered, that means the file is sorted, then the IO cost will be ordered here, sorted here, then the IO cost will be log base to n, where n represents the number of blocks. And if it is coming in the points like 2.7, this means that two blocks are not sufficient to locate all the records. So here we have to take the seal value. Seal value means the upper value. That means three blocks needs to be transferred from the secondary memory to the main memory. This is the IO cost for the ordered file. Next one is for the unordered file. So here the IO cost will be unordered means unsorted elements are there. तो हमारे पास कोई choice नहीं है apart from the linear search, and we know that the time complexity for the linear search is order of n. So this is going to take n blocks. IO cost will be, we need to transfer n blocks from the secondary memory to the main memory, whereas in case of ordered file, we need to transfer log n blocks from secondary memory to main memory. Make sense? ये clear हुआ? Now, sometimes, अब यहाँ पे अभी तक हमने कोई indexing use नहीं किया, we have not created the index file. Let's assume हमारे पास book में 1200 pages हैं and I want to search for some particular chapter. तो अगर 1200 pages है, I'll be swapping one page after the another. That in the worst case scenario, I might end up by swapping 1200 pages. That means a lot of time is like wasted. So better idea is, कभी भी हम कोई भी large files हैं, if 5000 pages are there, तो क्या हम 5000 pages को swap करेंगे? Obviously not. If we increase the number of pages, number of swaps will increase. That results into more time required to access a record. So better idea is कि एक index file बना दो. Index में we will be just having the topic name and the page number. Page number is nothing but that is the pointer. Okay, so here we have a concept of indexing. So if we are interested in accessing the data from the large database files, if we want to retrieve data from large database files, then we use the concept of indexing. In the index, हर obviously index कहाँ पे store होता है? Book के page पे. Page size is same for index file and for the main file. For the database file, the block size or the page size of the index file and database file is same. बुक में आपने देखा है कि इंडेक्स फाइल का पेज ऐसा नहीं होता है कि पेज साइज इज स्मॉल फॉर द इंडेक्स पेज एंड फॉर द रिमेनिंग कंटेंट द पेज साइज इज बिगर. पेज साइज, point number one, page size or block size for index file will be same. ठीक है, रियल लाइफ एग्जाम्पल से भी रिलेट कर लिया. What about the record size? Record size, block size and for index file and database file and database file will be same. Now, if we talk about the record size of index file, we have to do the comparison between record size of index file and record size of database file. Again, just consider book. Book में index page में आप देखते हो we are just having lot many spaces are there in one row because we are just considering the topic and the page number. Record में क्या store करवा रहे हैं? Topic, that is the key जिसके basis पे search करना है. For example, मुझे chapter name के basis पे search करना है. I want to search on the basis of the topic name, so that is behaving as a key, and here we are having the pointer. Key is nothing but that is the topic on the basis of what we are searching, and search key and pointer is nothing but the page number. Only these two things are stored in one row of a index file, whereas in the database file not many words are there because puri row full hoti hai because we are storing the data. So this means that the record size of index file is much smaller than the record size of the database file. Now we know the block size, we know the record size. So on the basis of this, we can find out the block factor. Block factor of index file and block factor of database file. What is this block factor of index file? That means block size divided by the record size. Let us assume that block size is 100 bytes, record sizes, record size for database file, this is 40 bytes. And we know that in index file का जो record size होता है that is much smaller than the database file. So I'm considering this as 10 bytes. So on the basis of this, we can determine the block factor for the database file. It comes out to be block factor for database file. It comes out to be 2.5. 100 divided by 40, that is 2.5. And if we find out it for index, obviously if you are dividing it with the smaller value, result will be more. Denominator में अगर value छोटी है तो result will be greater. So this means that block factor of index file will be greater than the block factor of database file. Okay. Now, this much is clear. अगर block factor of index file is more, that means on one page we can store more number of entries. So the index file size will be, or the number of pages in the index file will be less than the database file. बुक में अगर आपके पास 1200 पेजेस है तो इंडेक्स के जो पेजेस होंगे that will be 3, 4 or maximum 10, not more than that. So we know that the size of index file or the number of pages in the index file will be very, very small as compared to the number of pages of the database file. So let us assume that this is our database file. This is the database file which is divided into the blocks. Block 1, block 2, block 3, and so on up to block n. Block 2, block 3, and so on up to n blocks. And here we have an index file. In this also we have the blocks. File is divided into the blocks. Block size is same for both. We have already written that point. And this is block 1, block 2, and block n. Index file. Obviously the number of blocks in the index file, jitni bhi entries hai here will be having the pointers and it will be referring to the different blocks of the file or maybe referring to the same block. Okay, we are not concerning ki kaun se record ko point karwa rahe. So here this m value, m is representing, like for example हमारे पास यहाँ पे 4 blocks है index file में and here we have 1200 pages, 1200. So this means that the number of blocks are more than, much more than the number of blocks in the uh, index file. Correct? Yes. So on the basis of this, we have concluded that the number of blocks in index file is much smaller than the number of blocks in database file. Correct? Anyone having any doubt till this point? Now if I want to I want to find out the IO cost, मुझे किसी particular record को access करना है, तो मुझे सबसे पहले what I need to do is I need to refer to the blocks of the index file. Okay, since this file index file is always sorted, तो यहाँ पे आपके पास IO cost क्या आएगी? IO cost with indexing. What will be the IO cost here? I guess this is going behind my image, so for few seconds let me hide it. Okay, IO cost with indexing. अब यहाँ पे जो index file है that is always sorted. So here we will be just accessing the sorted है, ordered है. तो IO cost will be log base 2. कितने blocks हैं index file के? सबसे पहले हमें index में entry ढूंढनी है. Log base 2 m. जब आपको page number मिल गया, then we have to refer to that particular page. In order to access this particular page, जिस भी पेज पे डेटा अवेलेबल है, for that I'm adding here 1. These many blocks we need to refer. So this plus 1 is to access the particular block. And if we compare this cost, log base 2m plus 1, this is much smaller than log base 2n because n is representing the number of database file, a number of blocks in the database file, and obviously this is smaller than n. Make sense? ये क्यों आया? Because m is smaller than, very small as compared to n. So this is the IO cost for index file, and here we have, this is the IO cost for ordered file, and this is the IO cost for unordered file. For unordered file. Make sense? Now we have two categories of index. One is known as the dense index and other one is known as the sparse index. So dense index means for each and every record we will be storing the value. Let me show you my image. Okay. So there are two categories of index. One is known as the sparse index and other one is known as the dense index. Sparse index means for the set of records, yani ki for multiple records, there will be single entry in the index file. That is the concept of sparse index. What do I mean by this point? Let us assume that here in the database file, this is block 1, this is block 2, block 3, and so on and so on. यहाँ पे आपके पास कुछ entries हैं, okay? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So this is the database file. Now, in the sparse index, for a set of entries, this is just containing one entry. What it is showing for a set of entries like block के starting में record कहाँ से आ रहा है? So it's just first, it's just containing, it's just pointing to the first record of the block. Next one is 5. From the second block, it is just containing one entry. This is block 1, this is block 2. For each block, this is taking only single entry. This is what we are considering here. Okay, so this is nothing but this is the example for the sparse index. Here for a group of entries, we are just having one entry in the index file. On the contrary, in the dense index, for each and every record, there is an entry in the index file. Okay, that is known as the dense index. For every entry in the database file, there should be corresponding entry in the index file, yani ki number of entries. Here, number of entries in index file. Index file में कितनी entries होंगी? जितने records है, क्योंकि हर एक record के corresponding entry is there in the index file. So number of entries in the index file is equal to the number of records in the database file. Whereas if we find here the number of entries in index file, number of entries in index file, that is smaller than the number of entries in database file. And sometimes this is equal to the sometimes it's equal to the number of blocks, but not always. Okay, sometimes it depends on how you are storing the entries in the sparse index. Sometimes. Make sense? So this is about the categories of index. Now let's consider one practice question. Consider that the size of the block is given as 1000 bytes and the record size of the block is given as 1000 bytes and the record size is given as 100 bytes. So here let's take out the information. Block size is 1000 bytes. Record size, this is the record size of what? For the database file. This is given as 100 bytes, on which 12 bytes are the key field and 8 bytes is the pointer. So this means that it's providing the information related to the record of the index file. Because index file mein we have the search key field and the pointer field. So record size for the index, on the basis of this, we can calculate the record size of the index file. That is the sum of the key field and the pointer field. That comes out to be 20 bytes. After that, this is saying that the database consists of 10,000 records. So number of records are 10,000. एक फाइल में कितने records stored है? 10,000. So what will be the IO cost using the sparse index and dense index? I want you to find out the IO cost without index also. So first of all, let's talk about the IO cost without index. It depends on the number of blocks that we need to transfer. तो सबसे पहले हम क्या find करेंगे? We'll find out that how many blocks are there in the database file. कितने blocks required है? It depends on the block factor. So first of all, I'm finding the block factor of the database file. Block factor is block size upon, this is the block size. We have already written the formula, right? I need not to write it again. Block size upon the record size. हम block factor file कर रहे हैं database file का, so that is 100 bytes. So that comes out to be 10. So this means that in order to store 10,000 records, how many blocks are required? So number of blocks required to accommodate 10,000 records, number of blocks required. एक ब्लॉक में 10 रिकॉर्ड्स आ सकते हैं, तो 10,000 रिकॉर्ड्स कितने ब्लॉक्स में आएंगे? सो इट इज डिवाइडेड बाय 10,000 records divided by 10. That means 1,000 blocks are required to accommodate 10,000 records in the database file. Similarly, we can find out the block factor for the index file. Okay. First of all, without index, let's find out the IO cost. अगर file ordered है, if the records are sorted, if file is ordered, we know that the IO cost is log base 2 n. Just substitute the value of n here. N is coming out to be 1,000. So log base 2 1,000. And obviously we have to take the seal value. That is nothing but approximately that is 10. So IO cost is 10. So agar file ordered hai, you have to access any record from 10,000 records, then 10 blocks is the IO cost. That means secondary memory से main memory में 10 blocks transfer करने पड़ेंगे. But if the file is unordered, for unordered file without indexing, IO cost is n. We need to check for each and every block. Here the value of n is 1,000. So this is the IO cost for unordered file without indexing. Now I want to find out the IO cost with indexing. IO cost with indexing. That means we need to find out the block factor for the index file as well. So let us calculate here the block factor for index file. Block factor is nothing but block size upon entry size. Record size किसका लेंगे? Obviously index file का. So block size is given in the question, that is 1,000 bytes, because this is going to be same for the database file and the index file, but now the record size is 20 bytes. So this results into 50. This means that in one block we can store 50 entries. Correct? Yes. Now it is saying that using sparse index and dense index. So indexing may we have to consider the concept of sparse index. Sparse index may number of entries will be how much? Sparse index means for each block we will be storing only one entry. So here in index, how many blocks are required to store? I hope you are getting this point. इससे पहले हमने without IO index consider किए, without index, now we are considering with index. So that's why I have calculated the block factor for the index file. Guys, यहाँ तक clear है? So in sparse index, how many entries are there in a file? Hurry up. What are the number of entries in the file? Number of entries. No response. Number of entries of index. So block factor is coming out to be 50. If we want to find out the number of entries, that will be equal to हर एक block में से एक entry आ रही है. So number of entries in the index, that will be equal to number of database blocks, because corresponding to each block only one entry is coming up. So number of database blocks are 1000. Database blocks are 1000. So on the basis of this, we can return the number of index blocks. एक ब्लॉक में 50 एंट्रीज आ सकती हैं और आपको 1000 एंट्रीज को स्टोर करवाना है. सो नंबर ऑफ इंडेक्स ब्लॉक्स will be equal to 1000 divided by 50. That is nothing but 20 blocks. So on the basis of this, we can return the IO cost. IO cost with sparse indexes, it's log base 2 number of blocks in the index file plus 1. This is more than 4, so it comes out to be 4 point something, that is 5 plus 1, that is 6. IO cost with sparse index is 6. Next one is IO cost with dense index. Dense index means index file में कितनी entries आएंगी, corresponding to each and every record there will be the entry. So number of entries in index file is equal to how much entries will be there. For each and every record there will be the entry, number of records in database file. और कितने records given in database file में, it's given in the question, we have 10,000 records. So here we'll be getting 10,000. Just like here, we can find out the number of index blocks. Block factor already हम calculate कर चुके हैं. Number of index blocks required 10,000 entries को store करवाना है. एक block में 50 entries आ सकती हैं. So it results into 200. And IO cost is log base to m, that is index blocks. IO cost is log base to m plus 1. So m is nothing but 200. Take the seal value plus 1. 2 raised to power 7 is 128. So it will be 2 raised to power 8 is 256. So it will be 7 point something. 7 point, let's assume 6. Kuch to value it. Just check it out. Anyhow, we have to take the seal value. That means we'll be taking the next value. It is coming out to be 8 plus 1. That is 9. So this is the answer. So we have like summarized whatever we have discussed. We talked about the IO cost without index. So IO cost without index में हमने दो concept discuss किए हैं, for ordered file and for the unordered file. We have got the cost for ordered file and for unordered file. Under the indexing, as of now, we just have talked about the sparse index and the dense index. So sparse index number of entries in the index file is equal to the number of blocks in the database file. So that's why we have taken the blocks. And in the dense index, corresponding to each and every record, there is an entry in the index file. So that's why here the number of entries in the index file are equal to the number of records of the database file. Correct? So whatever concepts we have discussed corresponding to that, we have solve one numerical जिसमें हमने सारे आंसर्स फाइंड किया. I hope that this is clear to everyone. So here is the IO cost. You can try this numerical again. This will clear your all the concepts that we have discussed till now. Now after this, let's quickly have an overview of the types of index. So there are three types of index that can be constructed over any file. First one is the primary index. Primary term, we know that we do have one concept of primary key. तो it looks like कि यहाँ पे कुछ key का concept use हो रहा है. That means जब हम index बनाते हैं, two things are used. One is whether the file is ordered or unordered, and the second thing is the search key attribute that we are using, whether that's a key attribute or not. तो ये जो types है, it depends on the properties कि जो फाइल के ऊपर आप इंडेक्स क्रिएट कर रहे हो, whether that file is ordered or unordered, and whether the search key field is a key field or not. So primary index में I'm so sorry. So in the primary index, this primary index is created when two conditions are satisfied. पहली condition क्या है? File should be the ordered file, यानी कि entries should be sorted. And second one is जो search key field है, that should be the primary key or the alternate key of the database. Primary key means will be having the unique entries. Unique entries will be there. And for each relation, there will be at most one primary index is possible for primary index for a database. एक ही primary index बन सकता है, not more than that. Because here we are using the search key field and that is ordered, right? Here, what will be the type of database that will be created? Primary index है, आपके पास unique entries आ रही है. So for multiple entries, we can store one entry, or corresponding to each entry, we can store the entries. So this primary index can be sparse बना सकते हैं because unique entries है, ordered है. For the set of values we are taking one value. जो अभी हमने example ली थी 1 2 3 4, first block से we are just storing 1. 5 6 7 8 we are storing only 5. So sparse index can be constructed for the primary index, or dense index is also possible, because it's your choice whether you want to take the single entry or for each every record you want to store the entry. So this primary index can be sparse or dense, but obviously sparse index will be preferred because the IO cost is less for the sparse index, क्योंकि sparse index में number of entries ही कम है. So but sparse index is preferred. Correct? Next one is the clustering index. So clustering index will be constructed if the file is ordered, file ordered है, but जो key field है that is not a search key is not a primary key. Primary key means here for each ID we are having multiple entries like 1 1 2 2 2 and 3 3 3 4, something like this. So for set of values we are just storing one value. 2 को हम index file में दो बार नहीं लेके जाएंगे, right? For 3 we are getting one entry. So these are the entries in the index file. What we are doing is for a group of entries we are just taking one entry, and this is a property of what? This is done in the sparse index. This means that the index that is constructed for the clustering index, cluster का मतलब क्या होता है? Group. For a group of values, we are just taking one value. So that's why here we are getting a sparse index. So clustering index is always, it's at most one क्लस्टरिंग इंडेक्स. एक से ज्यादा क्लस्टरिंग इंडेक्स फाइल के लिए नहीं हो सकता, क्योंकि जब आप फाइल को ऑर्डर करते हो, ऑर्डरिंग कैन बी डन ऑन द बेसिस ऑफ ओनली वन एट्रीब्यूट. या तो आप स्टूडेंट आईडी के बेसिस पे ऑर्डरिंग करोगे, या फिर मार्क्स के बेसिस पे ऑर्डरिंग होगी, या फिर नेम के बेसिस पे ऑर्डरिंग होगी. यू कैन नॉट order the file on the basis of multiple attributes. So that's why only one clustering index is possible. I could have written here possible. Okay. And what type of index we'll be using here? Clustering index can be, it's only the sparse index, because for a group of entries, we are just taking one entry in the index file. It's the sparse index. Next one is the secondary index. Secondary index is for, okay, secondary index is for the unordered file. Ordered के लिए हमने search की field भी देख लिया, primary key and non key भी देख लिया ordered के लिए. Now for unordered file, index is said to be secondary index if the following conditions are true. Search key may or may not be used. तो आपके पास key field हो भी सकता है और नहीं भी हो सकता. And key is a search key that can be key can be search key can be key or non-key, whereas the file is unordered. It should not be used for physical ordering of the database. That means we are talking about unordered file. Unordered file. So this can be constructed even if the primary index and clustering index is available, then also we can construct this clustering index. Then also we can construct the secondary index. Okay, so we can write here secondary index is possible. Secondary index is possible even when primary index or clustering index already exists. Okay, so this secondary index, क्योंकि file unordered है, तो हम we do not know where the entries are available. So this means that we have to store each and every entry in the file. So this secondary index is always the dense index. Correct? Make sense? I should write here always pass. So secondary index is always dense index because the file is not sorted. It's unordered. So this is about the types of index. So let's go through the summary. जो हम index create कर रहे हैं, that is on the basis of ordering and the key. Anyone having any doubt? This is the summary. So here we have the ordered file, unordered file, we have a key field and non-key field. If file is ordered and there is a key, then definitely what sort of index will be constructed here? This will be the primary index. If the file is ordered and we have a non-key, then in that case, clustering index will be constructed over the database file. If it is unordered file, doesn't matter whether the search key field is a key field or non-key field, so secondary index is created. Here also we'll have the secondary index. Okay, so here this secondary index is based on key and this is based on non-key. So this is all about the types of indexes. I thought of giving you the introduction to the multi-level indexing. Sometimes what happens is if we are dealing with really a large database, then in that case, the size of the index file might be large, right? हो सकता है कि index file में हमारे पास 20 pages आ रहे, 30 pages आ रहे. So in that case also, if we are going to transfer the blocks from the index file, so it might be taking more time. तो हम क्या करते हैं, जब index file का भी size large हो जाता है, we create the index over the index, that is known as the multi-level indexing. और कब तक index के ऊपर index create करते हैं, until we have a single block in the last level of the index. Okay, so that results into multi-level indexing. Anyhow, today I guess we have discussed lot many concepts, so I'm not going to discuss anything about multi-level indexing. So in the next session, we'll continue our discussion with the multi-level indexing. First of all, we'll have a look over the concept of static multi-level indexing, then we'll go for dynamic multi-level indexing. Dynamic multi-level indexing may we will be talking about the concept of B tree and B plus tree. Very very important. If you can understand the concept, then आपको कोई भी formulas को याद करने की जरूरत नहीं है, and obviously आप confusion को avoid कर सकते हो. Otherwise lot many concepts are there in the B tree and B plus tree, and definitely that's a important topic क्योंकि डेटा स्ट्रक्चर्स में भी कवर करते हैं हम ट्रीज में और DBMS में, but actually its application is under the indexing because this is used to support dynamic multi-level indexing. So I'll be covering the concept of B tree and B plus tree under DBMS. I'll not again cover that topic under data structures. Okay, so please take a note of this point. So let's leave this as of now. So guys, those who are new, we have a Telegram group. In another 15 minutes, I'll be sharing the PDF in the group. So you all can join this Telegram group if you have not joined so far. And the Telegram group name is Shefali Ma'am Testbook. Link is given in the description box. Let me share my screen with you guys quickly. Uh, okay. I hope my screen is visible. So currently this video is, what happened? Just give me a minute. ओके, तो अभी ये वीडियो चल रही है. जैसे ही आप इसके डिस्क्रिप्शन में जाओगे, फर्स्ट वन इज फॉर द मास्टर क्लास सीरीज. सो दिस इज द मास्टर क्लास फॉर द गेट CSE. This is 100% achiever master class. Why is it 100% achiever? Because in the master classes we are just covering the previous year questions and the practice questions. जो भी concept हम YouTube पे cover करते हैं, इसके questions हम लोग master class में करते हैं. Today's master class will be based on the PYQs of serializability, जिसमें हम complex serializable और view serializable के questions करेंगे. Apart from this, you can, if you're targeting on the NIC, then you can join the NIC Super Coaching. This is the second link. Third link, I was talking about the third link. This is the link for the Telegram group. Okay, so if you are preparing for the GATE exam or any other exam, then this group might be useful for you guys. So join this link. If you want to join the super coaching, then click on the fourth link and it will take you to the Testbook page where you can see lot many options, what courses are available under the super coaching. Let me quickly give you an idea that what is the super coaching. Super coaching is basically containing a series of the recorded as well as the live sessions. So recorded sessions may complete courses available by multiple educators, multiple super teachers. So here we you can see here three tabs are there which is representing the all courses, full courses and subject course. So in order to save the time, I'm just going to the full course. जब आप फुल कोर्स में जाओगे आपको टॉपिक बाय टॉपिक कोर्सेज मिल जाएंगे. So, complete course is provided by the Gate Forum, by Digimento, by Nimbus Learning, and by me and my team. So, under this 250 videos are there, and this course is in the English language. That's a combination of Hindi and English. So, you can view the details of the full course. You can download the course curriculum. So, you will get the clear idea. And this, on the basis of this, when you have learned the concepts from here, then you can join the live series जिसमें हम quick revision करते हैं सारे topics की दोबारा से, and after that we are going to have the doubt session and the PYQ session. Okay, ये सारे sessions live series में जाएंगे. अब इतने सारे courses क्यों available है? Because हो सकता है कि आपको एक topic के ऊपर और ज्यादा clarity के लिए आप you need some more resources. So we are just providing one platform where you can explore the remaining resources as well. Okay, तो आपके पास multiple resources available है एक topic के लिए अगर आपके पास time है and you want to refer, you can do that. Okay, you can have a look over the profile of the super teachers if you want to join the demo class before joining the super coaching batch. That is also available. Then we have a live series in which we'll be having the quick revision and the discussions. Mock test, this is going to cover the mock test series, PYQs, each and every kind of questions will be covered under this series. Then is the study notes, जैसे इस session के लिए मैं PDF दे रही हूँ, this way you will be getting the PDF notes for all the subjects in detail, including engineering mathematics and general aptitude. Apart from this, engineering mathematics, general aptitude और computer science में आपके पास सारे के सारे technical subjects आ जाएंगे. अभी के लिए ये locked है because subscription is not activated yet. But जैसे ही आपकी subscription activate होगी, topic by topic, हर subject के अंदर unit by unit PDF notes हैं. For one unit there is one PDF. And apart from this, formula notes are there, which are the shorthand notes, which you can refer before your exam. Okay, and yeah, this is also like under the law. So for this, if you want to join this, we have three plans: 3-year plan, 2-year plan, and 1-year plan. 1-year plan is basically for the students, those who are in third year or fourth year. They have some idea that what all things are there, and if you are in second year or third year, I'll refer you this 2-year plan, because second year is the best time to start with the preparation. You will get enough number of time for the preparation, because जो सब्जेक्ट्स हैं गेट सिलेबस में वो सारे सेकेंड और थर्ड ईयर में कवर होते हैं बीटेक के. ओके, core technical subjects of third semester, fourth semester, fifth semester, and sixth semester all will be covered here. This will give you the benefit in scoring within your semester exams and the campus placements and everything. So it's one-stop solution. So fees भी बहुत ज़्यादा नहीं है. For 24 months, it's not even 24,000. तो per 1,000 से भी कम price आ रहे हैं. So definitely, and lot many benefits are there. And trust me, guys, if you have prepared well for the GATE exam, not to prepare the technical portion for the other exams. Okay, like ISRO का भी notification आया, तो अगर आपकी GATE preparation अच्छी है, तो you can directly fill out the ISRO exam, and majority questions will be the previous year GATE questions. So you will get the benefit in that. In order to get the full benefits, to get extra discount, you can use here the coupon code, that is Shefali S. And this coupon code is also given in the description box. आप यहाँ पे देख सकते हो. If you want to join the super coaching, then you can use this coupon code Shefali S. Okay, so this is all about from my side. Now let me tell you that in the upcoming sessions, what we are going to cover. So today definitely we'll be having a master class. जो लोग पहले से sessions देख रहे हैं, they know that what is the time of the master class. For others, I am going to tell you. Anyhow, in the next session, we will be talking about the multi-level indexing. But before that, guys, daily from Monday to Friday, we are having 2 sessions. One on the YouTube, that is at 4 p.m. to 5 p.m. Today we got late because of the lengthy topic YouTube session. In this, we are just covering the concepts. And from 8 p.m. to 8:30 p.m. we have a master class. This master class is free. Master class, obviously this is free. And in this we are covering the questions on the basis of the concepts that we have covered. पहले हम same day पे कर रहे थे, but many of you wanted कि same day पे ना करके एक दो दिन के बाद करें ताकि आप बीच में concepts को revise कर लो. So we are doing the same. So already serializability का concept हम Wednesday तक खत्म कर चुके. But in today's master class, I'll be covering the concepts from the serializability. Not concepts, questions from the serializability. Saturday and Sunday we have the marathon session. So I'm planning to take the marathon session on multi-level indexing. Okay. Now next topic is multi-level indexing. So I'm planning कि हम इसको marathon में कर ले, because this is a lengthy topic. Otherwise हमें दो दिन में खत्म करना पड़ेगा. In 1 hour, it's not possible to cover all the concepts of multi-level indexing. Okay. All right. So this is all from my side. If you guys have any query or any doubt, you can ask. Otherwise, we'll end our discussion here. I guess there is no query. So this is all from my side. I'll see you at 8 p.m. in the master class. So be ready with your doubts on serializability and do revise. Do try to solve the previous year questions on serializability if you have not done yet. Okay. Thank you so much, guys. Bye bye.